Okay, so we're going to start reviewing for this chapter on equations and inequalities. We'll start this today. We'll finish it off tomorrow. Also, tomorrow we'll go through the 2 quizzes you guys wrote in this chapter. And then your test is Wednesday. So the first thing we did is we solved equations. An equation is where you have an equal sign between a left and right side. And we want to find the value of the variable that makes the equation true. And so we did that by looking at the equation. Sometimes we had to do some simplifying first, but we needed to get the variable by itself. So for question number 1, there's a couple different ways we could do this. I would probably start by multiplying the brackets out because this always works. Okay, but in this case, you could divide both sides by 5 because on the left side, 5 is a factor. It's 5 times x minus 4. And the right side is also divisible by 5. So if you do that, it actually saves you a step. And we can only do this because both sides are divisible by 5. The other option, like I said, you could multiply out the brackets and then get the x by itself from there. But because both sides are divisible by 5, and this only works because it's a 5, and then the bracket means times the x minus 4. So the 5 is multiplied by the x minus 4. When we divide both sides by 5, they will cancel. And you're left with x minus 4 on the left, equaling on the right, 25 divided by 5 is 5. And then we just have to add the 4 to both sides to get x by itself. And on the left side, the 4's will cancel. You'll have x by itself. And on the right side, 5 plus 4 is 9. And there's your solution. And we always check to make sure that our answer is correct. On the test Wednesday, if it tells you to check, it'll be worth a mark. If you don't check, you will lose that mark. No matter how trivial it may seem, if it asks you to check, you got to make sure you do that. And so that one checks. We've just shown that when x equals 9, the left side equals 25, which is what the right side is, so it checks. Question B can be done the same way. Both sides are divisible by 6. Okay, on the left, it's 6 times m plus 3.2. Those two are hooked together by multiplication, so we can do the opposite. We can divide both sides by 6. And this again works because the right side is divisible by 6. On the left, the 6's cancel. That's why we divided both sides by 6. You're left with m plus 3.2 on the left, and on the right, that equals 24 divided by 6, which is 4. Then to get the m by itself, we would subtract the 3.2 from both sides. So the 3.2's cancel on the left. We have m by itself. On the right, 4 minus 3.2 is 0.8. And so there's our solution. And to make sure, we do our check. Make sure that the left and right side give us the same value. So on the right side, we have 24. On the left side, when we let m equals 0.8, working out inside the brackets first, 0.8 times 3.2 is 4, and 6 times 4 is 24, so it checks. We've just shown that our solution is correct. Right? Question C can be done the same way. Both sides are divisible by 3, but because it's a negative 3 in front, that's what we're going to divide by. And this is an equation. Remember, when we solved inequalities, if we multiplied or divided by a negative value, the inequality reversed. That's not what's happening here. It's not an inequality, so we don't have to worry about switching it around. There you go, Shyla. Yep. Okay, so on the left, negative 3 divided by negative 3 cancels. You're left with m minus 3.1 equals, and on the right, 18 divided by negative 3 is negative 6. Then, to get the m by itself, we'll add 3.1 to both sides. And so the negative 3.3 plus 3.3 cancel. You have m by itself. And on the right side, negative 6 plus 3.1 is negative 2.9. And again, if you're not sure, use your calculator. Negative 6 plus 3.1 is negative 2.9. So we have negative 3 bracket m minus 3.1 equals 18. So it's negative 3 bracket negative 2.9 minus 3.1. And again, you can use your calculator to combine those two values in the bracket. You're going to get negative 6, but just to make sure, negative 2.9 take away 3.1 does equal negative 6. And negative 3 times negative 6 is positive 18, so it checks. Our answer is correct. Okay. Question D, we could do that by dividing both sides by 3. But let's do this one by multiplying out the brackets. When you multiply everything inside the bracket by the 3 in front, you're going to have 3 times negative 5.6, which is negative 16.8. And then to get the 3a by itself, we will add 16.8 to both sides. On the right side, left side, excuse me, the 16.8s cancel. You have 3a by itself. And on the right side, 9.6 plus 16.8 is 26.4. And then to get the a by itself, we will divide both sides by 3. On the left, the 3's cancel. And on the right, we have the 26.4 that's divided by 3, which is 8.8. So there's our answer that we need to check. So on the left side, we have 8.8 take away 5.6. I think that's 3.2, but let's check. 8.8 take away 5.6. Yeah, 3.2. That gives us 9.6 on the left, which matches what we have on the right. So we know our solution is correct. It checks. So for these next two, there are no brackets. So we're not multiplying anything out or dividing both sides by the same value at the start. But we have x's on both sides, so that's what I'll start with. I'll collect the x's. I will subtract the x from both sides. And the reason we do that is on the right side, those x's cancel. 3x, take away 1x is 2x's. Remember, when you're adding and subtracting like terms, the powers don't change. That only happens when you're dividing or multiplying x's together. If you have 3 of something and you take away one of those things, that leaves you with 2 of them. So now we're going to get the 2x by itself by adding 3 to both sides. So on the left side, negative 3 plus 3 cancels. We're left with 2x on the left. And on the right, 15 plus 3 is 18. And then we'll divide both sides by 2. The 2's cancel. And on the right, 18 divided by 2 is 9. So there's our solution, and that's what we're going to use in our check, which again always starts with the original equation, and we let x equal 9 on both sides. Three times 9 is 27, and 27 take away 3 is 24. On the right side, you'll have 9 plus 15, which also equals 24, so it checks. Because we get the same number on both sides, that means our answer is correct. So it checks. Question F, we've got m terms on both sides, so we're going to collect those together. In this case, I'd probably subtract the 5m from both sides, just so we don't get a negative value with m. It'll still work no matter what, but it's just easier maybe if we try and avoid getting any negatives in there. So on the left, when you subtract the 5m, they cancel, and you're left with plus 2 on the left. And on the right, 9m take away 5m is 4m, and then you have the plus 26. So next I would subtract the 26 from both sides because we want to get the m term by itself. So on the left, 2 take away 26 is negative 24. And on the right side, the 26 is canceled. You're left with 4m. Thank you. Come grab this review notes. So now we'll get the m by itself by dividing both sides by 4. And on the left side, negative 24 divided by positive 4 is negative 6. And on the right side, the 4's cancel, and we're left with m. So we have 5m plus 2 equals 9m plus 26. We need to show that we get the same value on both sides when m equals negative 6. So on the left, 5 times negative 6 is negative 30, plus 2 is negative 28. On the right, 9 times negative 6 plus 26. 9 times negative 6 is negative 54. And negative 54 plus 26 is negative 28. We get the same thing on both sides. Shows that the answer is correct. So you should never get these wrong, because you can always check to make sure the answer that you get makes the equation work. Should never get these wrong. Okay? So on to the next page. More equations to solve. For question G, I'd probably start by subtracting the 1.5a from both sides. So on the left, 1.5a, take away 1.5a cancels. Notice that you have a negative sign in front of that 2.6, so it's got to stay there. And on the right side, 2.4a, take away 1.5a is 0.9a plus 1. Next, we'll get the 0.9a by itself by subtracting 1 from both sides. So on the left, negative 2.6, take away 1 is negative 3.6. On the right side, the 1's cancel, and you're left with 0.9a. Which, to get the a by itself, we would divide both sides by 0.9. So they cancel on the right side, and on the left side, we have negative 3.6 divided by 0.9, which is 4, I think, but we'll check to make sure. Yep, negative 4. So there's our answer, and that's the number that we need to use in our check. So 1.5 times negative 4 should be negative 6. Yep. And negative 6 take away 2.6 is negative 8.6. And on the right, we let a equal negative 4. 2.4 times negative 4 is negative 9.6. Plus 1 is negative 8.6. So it checks. It checks. On question H, probably what I would do here is, because I have one fraction on the left by itself and one fraction on the right by itself, I could just go to cross multiplying if I wanted to. And that can only work because it's a single fraction on the left and a single fraction on the right. You cannot do that for the next question, for question I, because it's not just one single fraction on the left and one single fraction on the right. It's not even a single fraction on either left or right. So you can't cross multiply there. But for question H, we can, and that just makes things a little bit easier. Cross multiplying works whenever you have two fractions that are equal to each other. And I showed you before why that works. So it doesn't matter which pair we start with. Yeah, I think the review notes are on your binder there. So I'll start with the 3 on the bottom left times the a plus 2 on the top right, and that has to equal the 4 on the bottom right times the a minus 3 on the top left. So now we have to multiply out the brackets. We can't divide both sides by 3 because 4 is not divisible by 3. And we really shouldn't divide both sides by 4 either, because although 3 divided by 4 will give you a terminating decimal, we're still going to have a decimal to work with, which we want to try and avoid. So I'm just going to multiply out the brackets next. So 3 times a, and then 3 times positive 2. On the right, 4 times a, and 4 times negative 3. So now I will subtract 3a from both sides. On the left side, they cancel. You'll have positive 6 left on the left, 4a take away 3a is 1a or just a. And then you have the minus 12 that we would get rid of by adding 12 to both sides. So 6 plus 12 is 18. On the right side, the negative 12 plus 12 cancel, and you have a by itself. So there's our answer, a equals 18, and that's what we need to use in our check. So before we do this, I just want to mention one thing. On the left side, you have a minus 3 on top, 3 on the bottom. You cannot cancel the 3's. You cannot do that. You can only do that if all the terms on top are divisible by 3, and they're not. Okay? So we're checking. When we let a equal 18, what do we get? So on top, 18 take away 3 is 15, and 15 divided by 3 is 5. On the right side, you have 8 plus 2 all over 4. 8 plus 2 is, 18, not 8. So that's 20 over 4, which also equals 5. So it checks. We get the same value on both sides, tells us our answer works. It's correct. Question I. I would first simplify a little bit by combining the numbers together. Kira? Okay. So we'll add 4 to both sides. And so that at least simplifies it a little bit. On the right side, the minus 4 plus 4 cancels. We have 1/2 m plus 6, because we added the 4 and the 2 together, equals 1/4 m. So we got fractions on both sides. Keen? We're going to get rid of the denominator by multiplying both sides by the common denominator. Our denominators are 2 and 4. The least common multiple of those two numbers is 4. So we have to multiply everything by 4, including that 6. So we're multiplying everything by 4. And the reason we do that is we can divide. 4 divided by 2 is 2m, plus 6 times 4 is 24, equals, on the right, 4 divided by 4 is 1m, or just m. Here, we need the review notes. Like that. And that. Yep. Okay, so now we need to get the m by itself. And so what I would probably do is I would subtract 2m from both sides. It is going to mean that we're going to get a negative on the right side, but as long as you do everything correctly, that's fine. On the left, 2m, take away 2m cancels. You have 24 on the left. On the right, 1m, take away 2m is negative 1m. And so now if you divide both sides by negative 1 to get m by itself, you have negative 24 equals m. Negative 1 divided by negative 1 is positive 1m, or just m. So there's our answer. That's what we need to use in our check. So it's 1/2 times negative 24 plus 2. Half of negative 24 is negative 12. And negative 12 plus 2 is negative 10. So the right side better equal negative 10 as well. Otherwise, we've made a mistake and we need to check that. 1/4 of negative 24 is the same as negative 24 divided by 4. That's negative 6. Take away 4 is negative 10, so it checks. You get the same thing on both sides, means our answer is correct. So again, you should never get these wrong because you can always check them. Question J, multiply out the brackets. You'll get negative 6a and negative 3 times 4.2 should be negative 12.6, but let's check that. Negative 3 times 4.2, yeah, negative 12.6. On the right, when you multiply out the brackets, it's 4 times a, and then 4 times 3.8 is positive 15.2. So I will add 6a to both sides. On the left side, negative 6a plus a cancels. And on the right side, 4a plus 6a gives us 10a's. So I can get the 10a by itself by subtracting 15.2 from both sides. So on the left side, negative 12.6, take away 15.2 should be negative 27.8, but let's check. Yep. And on the right side, the 15.2's cancel, you're left with 10a. So now when we divide both sides by 10, we should get negative 2.78 on the left, which we'll check just to make sure. Yep. So there's our solution. And that's what we need to use in our check. And I'm kind of running out of room here, so let's move this stuff down. So on that left side, inside the brackets, we have negative 2.78, and we have to add the 4.2 to that. That gives us 1.42 inside the brackets. And that should equal the right side, negative 2.78 plus 3.8 inside the brackets, positive 1.02. So something is not right here because we're going to get a negative value on the left and a positive value on the right. Oh, this is positive on the left there inside the brackets. Nope. Okay, so let's go back and check. So that multiplication was right. That multiplication was right. We added 6a, which gave us 10a on the right. Negative 27.8 divided by 10a. Oh, no, that's right. Those are both negative. We added 6a to both sides. That's right. Left with negative 12.6. We subtracted the 15.2 from both sides, which gave us negative 27.8. That's going to be a positive. I forgot the 2 in front of the a. Where is there a 2 in front of the a? Oh, when I multiplied it out. Okay, that's it. Thank you very much. So that should be 2a. So that'll change that value and that value. So we want to go 2 times negative 2.78 plus 4.2, which is negative 1.36. And that gets multiplied by negative 3, 4.08. And on the right, when you multiply those out, you're also going to get 4.08. So it checks. It checks. Okay. Then we got into inequalities. And this is where if you multiply or divide by a negative, then the inequality reverses. So that's the only thing we have to be aware of. But for question A, that's not an issue because we're just going to simply divide both sides by 2. So on the left, we'll just be left with x. On the right, 12 divided by 2 is 6. So this says that all values of x less than or equal to 6 will work. So we graph our solutions on the number line. We put a 6 in the middle. And there'll be a closed dot on 6 because x can be less than or equal to that value. If it was only less than 6, then we'd have an open dot on the 6. But because the 6 is included, we have a closed dot. And now we're going to have an arrow going off to the left to show that that pattern continues, because less than or equal to 6 means that all values smaller than or equal to 6 work. And as we go to the left on the number line, we get smaller. Okay. Don't forget to put an arrow on the end on your assignment from last week that I marked. Some of you didn't put arrows on your lines, and that makes it incorrect or not fully complete. That means that that line stops or that pattern of numbers stop, and that's not true. Okay? So make sure you put arrows on your lines. Question B. I'd start by adding 2 to both sides. So on the left side, the minus 2 plus 2 cancels. I'm left with negative 4n greater than 16. Then we'll divide both sides by negative 4. Negative 4 divided by itself cancels, and you get an n. And now because we divided both sides by a negative value, now the inequality reverses. And 16 divided by negative 4 is negative 4. So there's our answer. Now, it doesn't say to check, but you can always do that just to make sure. All right, we're saying all values less than -4 should work. So let's check this one using -5. Using n equals -5. So I have -4n take away 2 has to be greater than 14. And when I let n equal -5, it's -4 times -5 take away 2. -4 times -5 is positive 20. Take away 2 is 18. That is bigger than 14, so it works. So on the number line, we'll put -4 in the middle, and this will have an open dot because n is less than -4 only, not equal to. So because of that, we have an open dot, and again, the line has to go to the left, and you need an arrow on the end to show that that pattern continues. So both of these were sets of real numbers, which are all numbers, all fractions, all decimals. That's why we use a line. For the next one, P is an element of integers. Integers are not fractions or decimals. They're only positive and negative counting numbers. So when we graph them, we use dots on our graph. But we need to get our solution first, so I will subtract 2 from both sides. Again, subtracting doesn't change the inequality. Only multiplying or dividing by a negative value changes the inequality. So on the left, the 2's cancel. We'll have 3p on the left greater than or equal to 17 take away 2 is 15. And then we'll divide both sides by a positive 3. So again, the inequality does not change. 15 divided by 3 is 5. So we have positive 5 in the middle. P is greater than or equal to. So because it's equal to, we'd have a closed dot on 5. And because we're only dealing with integers, we can only use dots there. And we also put an arrow to show that that pattern continues. This shows all integers greater than or equal to 5. Question D. I would add 4 to both sides. So on the left, the 4's cancel. You're left with 5u less than on the right. 6 plus 4 is 10. Then divide both sides by 5. They cancel on the left. You'll have u is less than 2 on the right. So we have to use any number less than 2. And I'm just going to do a check on this one. I'm going to check using the number 1. So on the left, I'll have 5 times 1 take away 4. That should be less than 6. 5 times 4 is 5. And 5 take away 4 is 1. That is less than 6. So it works. So on our number line, we'll put 2 in the middle. And we're going to have an open dot on 2 because the 2 is not included. U is only less than 2, not equal to 2. And because it's real numbers, we're going to use a line. And this line will go to the left because all values less than 2. So you have a line going to the left with an arrow on the end to show that that pattern continues. So there's that solution. Question E. Bless you. If we subtract 4 from both sides, that gets the negative 2L by itself. On the right, 20 take away 4 is 16. But now we're going to divide both sides by negative 2. And when you are solving inequalities and you divide by a negative, the inequality reverses. Instead of L being greater than, it's going to change to L is less than. And on the right side, 16 divided by negative 2 is negative 8. L must be less than negative 8. So again, if we wanted to check this, we use an integer, because that's what we're dealing with here. L is an element of integers. Less than negative 8 would be negative 9. So it's 4 minus 2L should be greater than 20. The left side should be greater than 20. So I'll have 4 take away 2 times negative 8. I'm sorry, not negative 8, negative 9. We're using our first integer less than negative 8, which is negative 9. Now on that left side, negative 2 times negative 9 is positive 18. And 4 plus 18 is 22. 22 is greater than 20, so it works. But our solution is that L must be less than negative 8. So we could put an open dot on negative 8. It's not included. And again, because we're dealing with integers here, we can only use a series of dots, not a line. A line means real numbers. It means all fractions and decimals. Integers are not fractions and decimals. Only positive and negative counting numbers. All right? For the last one, I would start by adding 10 to both sides. That gives us the negative 3r by itself on the left. On the right, 14 plus 10 is 24. Whoops, I put an equal sign there, and it should be a less than or equal to sign. And now we're going to divide both sides by negative 3, and because we're dividing by a negative value, the inequality reverses. So I'll have r by itself on the left, and I put an equal sign there again. The inequality is reversing. Instead of less than or equal to, it becomes greater than or equal to, and 24 divided by negative 3 is negative 8. So any integer greater than or equal to negative 8 should work. Let's check this one using, say, negative 7. That's an integer greater than or equal to negative 8. So negative 3r minus 10 should be less than or equal to 14. And negative 3 times negative 7, take away 10, is positive 21, take away 10, which is positive 11. That's less than or equal to 14, so it checks. So we're going to have negative 8 in the middle. It's greater than or equal to negative 8, so the negative 8's included. And because we're dealing with integers, we're going to go to the right with a series of dots. Because it's greater than or equal to, we go to the right. And because it's integers, we use a series of dots. Okay? So I'm going to stop there for today. We're going to finish this off tomorrow. We will also go through your 2 quizzes to help you get ready for your test, which is on Wednesday on this stuff. So I'll hand out the review assignment for you to start working on. These are always due for marks, so this will be due on Wednesday.